Amazon CTO Dr. Werner Vogels has published recently a number of predictions for the years to come. And one of them is the dawn of the Renaissance developer. Let's take a look. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today I want to react to this part of Werner Vogel's predictions, the dawn of the Renaissance developers. Let's first read what he's saying. There are also a few videos related to that where he expands a little bit, but the essence is this one. As generative AI reshapes how we build software, a familiar trope has re-emerged that developers will become obsolete. But this is not the end of the developer, it's the dawn of the Renaissance developer. Generative AI lets us generate code in seconds, but it doesn't sit in budget meetings where leadership debates cost versus performance. The core attributes of great developers remain constant. Creativity, curiosity, and systems thinking have continued to define the craft through every technological revolution. Developers who thrive in this AI-augmented world must become modern polymaths who understand that systems are living, dynamic environments. Let me tell you that first of all, I agree with this sentiment. Now let's first explain what he means by it. I'm gonna add a few more things that I've seen him talking about in a few videos. And then I want to add a few things from myself and from our team at Mozaic Works. So let's think this a little bit. You have the job of a developer that always was to understand the problem, to split the problem into smaller problems, and then to solve each of those problems in a way that makes sense for the business, for the context in which you live, that makes sense in the constraints of your product, of your business, in the technical ecosystem, and so on. With Gen AI, what happens is that you get less need to master all the technical details. We will still need that, but maybe 20% of the job will be done by these AI. So you'll have systems that are able to generate the code, and then what you need to do is to review that code, to improve it, to make sure that it solves the right problem within the right constraints. And even better than that, you need to do the first part better. And doing the first part better implies that you will be able to do more analysis. You'll be able to do more about security. You'll be able to do more about architecture. And by the point you end up giving a task to a coding agent or interacting with a coding assistant in order to generate the code, you will have gone through all these steps of understanding the problem, defining the constraints, knowing the domain, and all that. And this means that, the hard job is done, and then the rest of the job is to transcribe that into code, which is also something that can be difficult occasionally, but in most cases it will probably get automated. Not completely, I don't think it will be 100%, but there will be a lot of it. So this means that you need to be more of a T-shaped developer. So what um, Werner Vogels is saying in other interviews is that he's looking at this as a T-shape that becomes more of a T-shape. So as a T-shape, the idea is that you have one specialty and then you know more things that form the T. And he compares that with, there's the comparison with the Renaissance. Says Leonardo da Vinci, he knew how to sculpt, he knew how to paint, but he also knew mathematics, he also knew a lot more of other domains. And he didn't know mathematics as well as the other people, but he knew more. And I think Dr. Vogels is perfectly right in this prediction. We've made the similar predictions. I believe this is what will happen. Your role will become more blurry. You will need to learn more things. You will need to focus on solving problems rather than writing code. These are things that will change. But also because of that, you'll need to understand things at a higher level, at a different level. And let's then now focus on the second part, which is the conclusion. Developers who thrive in this AI-augmented world must become modern polymaths who understand the systems are living, dynamic environments. And let me give you now my opinion and our team's opinion of what the modern polymaths is about and of what this understanding that systems are living dynamic environments is about. First of all, what does it mean for a developer to become a modern polymath? And I believe there are at least three things. One, understand that software development is a humanistic endeavor. Applications are built for people. You need to understand the people you are building the application for. This becomes more important right now. Code is structured for people, at least until we'll only have agents that modify the code, which I'm not sure will come that early. So we still need to structure code for people, which means that you need to have this understanding of what other programmers need to know, need to understand from your code. These are humanistic needs. They are about people. So if you still believe that coding is completely, fully technical and there's nothing else about it, I'm sorry to say, but you'll need to change this. Second part of the polymath is that you need to understand what business you are in, the constraints, the domain of the business. Too many developers right now are somewhere in the middle of a large organization. They get some requirements, some specifications, they implement those and basically move data from one place to another, and that's it. Maybe they understand a little bit about what they are doing, maybe they don't understand the general context. And this just won't work anymore because the value of a developer becomes in solving problems. And if you can only solve the problems if you understand the domain, the questions that are being asked, and the constraints within which you are working. You need to understand those, you need to embrace them. Part of those constraints are market position, user base, who are you targeting, what part of the market, what are the things that, the features that will fit those personas. And of course, the technical questions that derive from that. But in order to get to the technical questions, you need to be familiar with the rest. Now, this doesn't mean that there won't be a role for very technically oriented people. I believe there will still be a role to play for people who are really good, that have a really strong expertise in, I don't know, databases or performance optimization, but it may happen that this becomes a skill that's no longer specific to a programming language like it is now. Maybe you'll do performance optimization in Java, C++, and Rust, because now you can. Maybe you'll do database optimization for 3 different or 5 different database engines. Again, polymath. You become a polymath. This also means that you need to stay curious. I've often heard developers saying things like, geography isn't useful, or economics isn't useful, or whatever. Philosophy isn't useful. This is completely untrue. It has never been true, but is now even less true than before, if I can say that. So you see, geography doesn't seem useful for programmers until you need to deal with time zones and the international dateline. Relativistic physics. You might think this is a curiosity until you need to implement software for GPS and satellites. Literature and philosophy, you might say, yeah, these are not, I want to write code, I don't want to know about that. But writing code is similar to writing prose. The domain-driven design ubiquitous language is actually a jargon, which is part of linguistics. And some of our modern dilemmas with using AI, with using technology, they have been discussed in philosophy, in literature, for a long time. We have that knowledge already. The more you know about the world you live in, the better you'll be at solving problems that serve the world. And that's basically where this Renaissance developer is taking you. The second part is that we need to understand that systems are living dynamic environments. We often think about technical systems as, you are writing code, you are putting it in production, users are using it, and that's it. That is not true. There are forces that act upon your software that push the architecture in specific directions. The most well-known example of this is Conway's law. Right? What does Conway's law say? That organizations are constrained to create designs that map their communication pathways. And this is a deep law in the sense that it shows that your organization, your communication structure influences, pushes, acts as a force on your software architecture. There are other forces that push your architecture in specific directions. There are the practices that you use. If you don't write a lot of tests, for example, and if your code does not have coverage, and if the code is not clean, you end up with parts of the code that you are afraid to change. And because you have parts of the code that you are afraid to change, you will end up adopting certain practices, like either we don't change that or we keep that. Whenever we change that, we need to retest it very in a lot of detail, and that can lead to release windows. While other teams might say, okay, we have full coverage, we trust our tests. Even if we don't fully understand that code is fully covered by tests, we have the courage to go in, change it, merge it, publish it, and it goes directly to production. And maybe we have some steps there. Maybe we have some kind of green-blue deployment, or however it's called. I always mix this up, where you monitor for a while and switch to the new version if it works correctly. So, and this makes you speed up your development. So your speed can be constrained by the decisions that you make. By the practices you use, by things like, how much trust do you have in your ability to change code safely. Technology can be a force that pushes your software in various directions. If you are using Microsoft or Java technologies, you are living within an ecosystem, and the way that ecosystem evolves will force you to evolve in various directions. So there are all these types of constraints, all these forces that exist and that are pushing your architecture in various directions. The more you understand those, the better you'll be at managing software on the long run. So what you should understand are things like Conway's law, Kinevin, complex adaptive systems. System thinking becomes an important part of your knowledge as a developer. This will become even more important with the introduction of independent agents in your systems, because those are the definition of complex adaptive systems. When you have agents that react in various ways to various inputs, and that can also communicate between each other, that is a complex adaptive system. You can only manage it by understanding systems thinking. It's a fascinating topic. Not enough developers have been exposed to it, other than collaterally by organizing into agile teams, although even then it wasn't properly explained more often than not. So what you need to do is to learn evolutionary architecture and cybersecurity. Now, cybersecurity is not mentioned here, and maybe it sounds like it comes from another place, but the thing is, cybersecurity, first of all, it's obviously needed for our systems. You obviously need to integrate it as a developer in your daily work, because otherwise you just won't end up where you want to be. In architecture, you need to pay attention to cybersecurity. And security is one of the forces that will push the way architectures are created and are evolving. And I believe it's one of the stronger forces that will act upon your architecture. So this is what I believe you need to know about systems. Systems are living, dynamic environments. There are more predictions coming from Werner Vogels. You can read those in the links that I added in the description box below. But this is the one that I think touches the most on what software development will become. And I think he's right. And unless we'll get AGI or something that completely replaces developers, which I doubt will happen very soon, then this is definitely what will happen, and you need to be prepared for the future. And by the way, we are here to help you. So we have courses on these things, and we can build a custom learning program for you, for your team, to be prepared for the future. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.